In this video, I'm going to introduce MapReduce. We don't use MapReduce necessarily in the modern way, but the sort of concept behind MapReduce we do still use. So for years, MapReduce was the dominant framework for distributed computing. MapReduce was implemented in the Hadoop environment. We'll say a few words about Hadoop down the road. And MapReduce was taking a problem and breaking it into chunks in a very systematic way. So MapReduce really consists of three steps. One of them is map, one of them is reduce, and then there's a third intermediate step. So we're going to do an example, so don't worry if all of this seems a little cryptic to begin with, but MapReduce starts with map. So each node is going to process a subset of the data and produce some kind of intermediate result. Not in the name, but an intermediate step is the shuffle step, where intermediate results are reorganized and moved across and around the clusters. Moving data is quite slow, so this step often dominates runtime. And then finally, reduce, where the group results are aggregated. And to give us a better idea of what any of this means, let's envision a simple example. I'm going to state a goal, count the number of times some specific words are used in the short stories of horror writer H.P. Lovecraft. And for this simple example, rather than look at all of his short stories, let's look at just a few of these. Um, I feel like I should say I am not endorsing H.P. Lovecraft. Very racist. Some pretty shocking stuff in some of these stories, but he does have a very distinct vocabulary, which is what I wanted for this example. He has words that he uses a lot that other people don't necessarily use a lot. So let's keep track of these three words: Cyclopean, Eldritch, and Aeons. And let's look at each of these steps. So starting with the map step, each mapper will deal with some of the text. And in real world MapReduce, you don't have, well, there are three texts. So just for simplicity, each mapper will take one text. And I was starting to say that real world MapReduce doesn't work like this. Some of these stories are longer than others. Maybe Shadow over Innsmouth gets a mapper, and the Call of Cthulhu takes up half of a mapper, and then at the Mountains of Madness takes up the other half of that mapper, and then blah, blah, blah. So this isn't exact. It's just illustrating the idea. So each of these mappers is going to take, for simplicity, one of the texts, and it's going to perform the task that we want to perform. It's going to count these words for its own text. So mapper one will deal with that text. Mapper two will deal with that text. Mapper three will deal with that text. Um, this isn't quite how things look in reality. The way MapReduce actually worked was that we'd have a bunch of ones, and Eldritch appearing twice would be represented very literally by Eldritch showing up twice, but I've decided to simplify things. And then after we do this, we will shuffle stuff around. In our shuffle phase, we'll group our data in a way that's more useful to us. So now, instead of having this word cyclopean that we're trying to count distributed over three different mappers, it's just showing up once. Same with Eldritch, same with Aeons, and then finally in the reduce phase, we can compute our final counts. So, generalizing from this toy example a bit, I mean, you're not always going to be able to do map reduce. We needed some stuff for this to work well. We needed the data set to be splittable into independent pieces. We need each piece to be something we could deal with separately. And then we needed to be able to combine the individual pieces. And not every problem you would like to carry out can be carried out like this. Having said that, a lot of very concrete, very real world problems do allow for this kind of processing. Like we'll see that linear regression does later in this week. One thing I should say is that I hope it's clear from this that MapReduce is a programming model. I mean, what I've just described, you could imagine implementing in Python yourself or R. I mean, maybe not easily, but this is a programming model, not a piece of software. So the system that sort of ran MapReduce was called Hadoop. And Hadoop ended up being very bloated. Hadoop was open source. People just sort of added whatever they wanted to. So Hadoop was a lot of things. But in terms of MapReduce, Hadoop was a storage system and then an engine designed to run MapReduce. And MapReduce has been kind of, not totally, but kind of replaced by Spark, which we're going to talk about next. The Hadoop distributed file system is still around. This still gets used for storing data. So, um, this is the idea. I mean, I'm framing it as the idea behind MapReduce, but to a large extent, it's also the idea behind Spark. Spark is built on MapReduce, and Spark is in many ways a successor of MapReduce.